Hello, we're going to do some more related rates because we love them so much. So here's our situation. Suppose you're drinking soda from a conical paper cup, because that's so easy to do. As you suck on the straw, soda leaves the cup at a rate of 8 cubic centimeters per second. And at what rate is the level of the liquid changing when the liquid is 7 centimeters deep? So let's go through all of our 5 not so easy steps. So we're going to draw our picture, which I've already drawn. Label variables. So first I'm just going to put some numbers on this thing, namely the fact that we have a diameter of 8 and a depth of 12. And that's the whole thing. Obviously, though, the actual, when you're looking at the liquid, you're looking at the radius and the height that are changing. So here's our drawing. I know I could put a 4 here also for that radius, but we have things drawn, we have variables labeled. I went to the radius just because of the fact that that's usually what you're working with on a cone. Let's list our know, want, and when. So the things we know. We know that the soda leaves the cup at a rate of 8 cubic centimeters per second. So that 8 cubic centimeters per second, that's a change of our volume. So dV dt is, and since it's leaving, we have to be really careful of this because the text won't say it's negative. We have to know that ourselves. So negative 8 cubic centimeters per second. And then at what rate is the level changing? So that sounds like what we want. So we want dH dt, that's our level. And when do we want it? Now. Or perhaps we want it when our height is 7. So there's our step 2. Step 1, draw it. Step 2, list your know, want, and when. So the next is writing an equation relating our variables, usually a common formula. So our variables are V, H, and R. So looking at that, I'm sure you all just happen to recall that the volume of a, use my words here, cone. This thing is a cone. I lost the word cone for a moment. 1/3 pi r squared h. So basically, if you had a cylinder, it would have 3 times the volume as the cone that would go inside of it. So I'm sure you all know that. Now looking at this, we have an issue because this formula uses R, H, and V. There's the thing we want, dV dt, or sorry, the thing we want, dH dt, and we know dV dt, but looking at this, we don't know anything about the radius, and that seems like a problem. And this is where a little bit of sneakiness is going to come in, because if we look at the radius and height of the whole thing, like the 4 and the 8 there, what we have, and I'm going to redraw this just so it's easier to look at, 8, it's not 8 though, it's 6. These are things we have to check, and I'm kind of glad I made that mistake. So it's a really common kind of mistake to make where you just have like a little brain fart. So it's good to be really paying attention. So then the thing that's changing is we have this R and this H. So you might notice that we have similar triangles. Remember that in geometry? Way back when, you can write an equation of like R over H equals 4 over 6. 6. No, not even 6. Goodness me. It's 12. What is going on with my brain? Is this how it's going to go today? Probably. That's a 12. That's a 12. 4 over 12. Goodness, you'd never know I worked this problem out in advance. I actually did. So R is equal to 1/3 H. Okay, so I'm going to substitute 1/3 H in. So I have, switch color here. V is 1/3 pi times the radius, which is 1/3 of the height. Squared times the height. So cleaning this up, I have being careful, 1/3, we have to square that too. It's 1, so we get 1/9 times a third is a 27th. So we have 1/27th pi h cubed. So this is like the sneakiest part of this problem of going, wait a second, wait a second, wait a second. This problem, our formula, we have 3 variables, but we only know about 2 variables. So we have to think this through carefully and go, okay, we got to make a change. And here's our change. Okay, so let's derive this guy with respect to time. I'm just going to write it back up here. So dv dt, the 1/27th pi, we don't have a product rule or anything like that. Those are just numbers. So 1/27th pi, and then times derivative of h cubed with respect to time. Remember, like you could throw that h in parentheses, so it's really 3, keep the inside the same of the h, squared times derivative of the inside, dh dt. So a little quality control looking at this, like the thing we want, dh dt, yes, that showed up. The thing we know, dv dt, yes, that showed up also. And when h is 7, that's there too. So we now have an equation that we can plug in all the things we know and solve for the thing we want, the dh dt. So it'd help if I plugged it in. So -8 equals 1/27th pi times 3 times our h, which is 7, squared times dh dt. I could have cleaned this up first, the 3 and this 27, but it really doesn't matter that much. So -8 divided by all of this stuff multiplying dh dt. Gosh, that's ugly. I will go ahead and do that little cleanup. So I have 1/9 pi times 7 squared. All of that in my denominator is my dh dt. So throwing that into our calculator, be really careful. In this, I'm actually showing you this because of the fact that I want you to be careful. So we have -8 divided by parentheses. We need those there because we're dividing by all of this stuff. 1/9 pi, and our human eyes see this as 1/9 pi. It really is 1 divided by 9 times pi, which is exactly what we have there, times 49. You could type 7 squared, obviously. So we have -0.4677, and it keeps going for our dh dt. Our final step is to simply plug in, well, we plugged in our numbers. I kind of skipped the solve for the desired rate. I kind of put it with step 5. That's totally fine, because it's kind of easier to work with just numbers versus having a bunch of variables. So remember, the last step, though, is to answer the question including units. So when the depth is 7, when the depth is 7 centimeters, the depth is decreasing. Let's say decreasing, even though the question said changing, let's say decreasing 0.46. And here's a weird thing. We can either say 0.467 or 0.468. As long as we have through 3 decimal places, it doesn't matter if we round or truncate, according to the College Board anyway. And then units, centimeters per second. So make sure you answer in words and, give that context basically, and including those units. We don't say decreasing a negative amount because that's weird. And we make sure we have those units, and since height is in centimeters and t is in seconds, we have centimeters per second. And there is our next equation. The only weird thing was in the similar triangles where we had to really think it through. Well, the other weird thing is the fact that I had problems with the height, but sometimes you have days like that. We all do. And that's important to know. We all have days like this.